It's a great pleasure to be here. It's amazing to meet all of you and have such a nice audience. So my name is Jacek, and I'm part of Distill Labs. You know, it's right here. That's our company, and I'll be talking about specializing small language models with less data. Right. So you've probably heard about small language models as smaller alternative to large language models, but I think what I want to touch today is how to make them into fine-tuned expert agents rather than just generic models that are, arguably a worse version of large models. So I think the first thing that I want to touch on is what is the future of AI products, right? And currently there are very many AI products that are simply a wrapper around GPT-4, wrapper around ChatGPT, or a RAG system, and it works just fine. But I strongly believe that as we go forward, all those GPT-4 wrappers are going to be somewhat deprecated, right? They're just going to be built into GPT proper. And what products can add value are those that are slightly more complex. We're going to process your data in many steps. Those so-called multi-agent systems have a few individual expert agents, each powered by a language model, chained together to get to the final result. So you won't be able to solve all of your problems with just a simple prompt, but you would have to chain a few of those individual tasks, like bite-sized tasks together, in order to build a proper vertical AI solution. And the second thing I want to argue for is a shift towards efficiency. So currently, it's all about building a new POC, getting some growth numbers, scaling up the user base. But as the time goes along, we'll want to finally maximize our profits, which kind of means trimming down the app, cutting out all the bloat, and making it very streamlined. Secondly, perhaps deploying those applications on device. So for privacy-focused customers, you would have essentially applications that need to run in their own hardware, not only on the cloud. Maybe you want to cut costs, maybe you want to be private, maybe you want to run it on mobile devices. In all of those cases, you cannot use LLMs, which is why you're going to need to have those multi-agent systems, like complex AI apps, running in a hardware-constrained environment. So, let us kind of touch on a little bit about what expert agents are. So this is a stack, an example stack of what we can expect from a multi-agent system. We first start with classifying our input text into some of the categories to select the right workflow. So if you can imagine, for example, a customer service application, we would have a lot of inputs, a lot of different types of customer questions that we need to classify to select the right workflows. Then we need a separate agent to extract all of the salient fields from the general chat to cut out all of the clutter. Finally, answer the customer question, right? If they want to learn about the product, if they want to learn about the documentation, and perhaps call APIs on their behalf to fix their problem. Maybe if their problem is, I want to learn about what is my expenditure last month, you might want to call an internal API to get that information for them. So in that sense, you probably need a few separate steps in this journey. Like, this is a very simple agent. You probably can write a page-long prompt to solve this, but in general, that's the idea. You would have those systems that compose of many individual agents. And the efficiency part, the solution here, I think, are small language models, right? If you want to build an app with an LLM, you can do that. You can just write prompts. But if you want this to run smoothly and quickly and on device, you need smaller models. You can't have a 600 billion parameter monster running on your own hardware, because you need about 200,000 to 300,000 euros worth of GPUs to actually host it. So in that sense, they're very efficient, and they can be secure because they can be deployed on your private infrastructure, right? Finally, the point is that they're smaller. So if you look at the benchmarks, obviously small models are just not as good, right? They're not as good as the LLMs. That's why you don't use it for everything. But I think that if you can fine-tune them to a very specific task, they can match the performance of large language models. And that's something that I will try to convince you throughout the majority of my talk, right? So if you can remember my previous slide about different agents, you can have a fine-tuned SLM for every of those tasks, and then all of them will match the performance of LLMs on their respective problems. So in a sense, you take advantage, you can have the cake and eat it too. You have a small, efficient model, but you also don't compromise on accuracy. So, I think the problem is that building expert agents like this is not very easy. So you need to label a lot of data, curate existing data, you need to actually do the training, right? It's not trivial. Like, you can use Hugging Face, but it's not gonna just work out of the box. And finally, you need a lot of infrastructure to get things going. I think the model training and infrastructure, I imagine that you're very skilled developers. You can hack it. I'm sure you can able to get this to work. But the data labeling and curation part is a really extensive manual process. And you need about 10,000 of well-labeled examples to get anywhere with model training. And this is something that can take weeks. You need to engage with data annotation teams. If you want to annotate it yourself, then that's hell. Like, no one really wants to do that. So I would argue that it's a big blocker for a person in this audience to train an expert agent to become become part of your multi-agent systems. So I think one solution that is pretty kind of popular recently in the media is knowledge distillation. So the name of our company is Distill Labs. So obviously this is what we work on, and this is a process that can help you train a small fine-tuned model to narrow it down to become an expert agent without having to annotate tens of thousands of data points. So we start with a task description, which is your prompt, right? This is the prompt that you would have if you run GPT-4. A few training examples. This is really tens of examples. So in the demo later, I'll show you how to train a model with 50 examples. But in general, that's about the right ballpark. It's something you can write yourself over an hour. And then any unstructured data about the problem, right? So you kind of take any documentation, any unlabeled inputs, all of what you want to pass through your system, you just dump it in, and we will take advantage of that. Internally, our platform goes through a process of generating synthetic data about your problem, so curating your examples and generating more examples like it, and then validating the generated data. So this loop goes on and on up until we have a nicely curated data set, and we take care of the fine-tuning for you. So this is all automated end-to-end. And finally, you can download an expert agent, and that's the model that you can get and you have full ownership of. So at the end of this pipeline, what you get out of our system is essentially the binaries of the model. So you have full ownership of it. You can deploy it in your secure architecture and self-host the model without having to have access to the cloud, right? So for any applications that you want to run stuff on mobile, on device, if you have a hardware-constrained environment, for a privacy-constrained system, or maybe you're building applications for environments without internet connection, this is a perfect solution. So today, we went through this stack of an example customer service application. So today I want to focus on the first step, classifying inputs into fixed categories, right? And I'll give you an example of how this workflow looks like on real data, so you can get a good understanding of what's going on behind the hood. But you could train all of those agents with our platform today, right? So we have a booth over there. I'll show you where it is after the talk, and feel free to ask us questions about how to train other expert agents for other tasks as well. All right, so how does it work? Let's have an example of the routing use case. I have a transfer fee charge. Those are the inputs that your customers might want to throw in to the chatbot, right? They want to ask, what's up with my transfer fees? And then the label is transfer fee charge, and that's the workflow that you want to route your customer request to. So our data set would have the task description and then many classes like that. So what we do inside is generate new data. So essentially, how can we generate more examples like the ones that you have provided? So if you add a small training data set, we will generate more examples like that, very similar, just diverse. Secondly, we will curate unlabeled data, right? So whatever you've provided as unlabeled data, we will use it to generate new examples. So for example, if you give us a generic, chatter, like a log of a generic chatter, we can make it a streamlined example that we can use for training the model. So Finally, once the data is curated, we remove any duplicates, we remove any incorrect examples, and we remove any examples that don't have the right structure. And that's more or less it. The loop just goes on and on up until the training data is created. So you don't have to trust me that it works well. We have created a few benchmarks on common data sets from the academic environment. You can see that in general, the teacher evaluation is in green, and our models are in pink, right? So it's green and pink. So in this case, the teacher evaluation is the Llama 405B model, so a large language model, 400 billion parameters. The small model here is a 1 billion model that has been fine-tuned for that specific task, right? So the point I'm trying to make here is that you can have a model that is 400 times smaller than the LLM, and 1 billion model is something you can run on your laptop. Even my MacBook Air can run a 1 billion model. So any deployed system, you can really make it work. And this is sometimes, well, in one case, you can outperform the teacher, but in most cases, it matches the accuracy of the teacher model. So the pink and the green lines are, almost at the same level, which means that you don't lose any accuracy by going towards a model that is 400 times smaller, right? That's kind of the main take-home message. That if you fine-tune it, you can really get a good result. All right, so I have 10 minutes left. I'll jump on in the back, and I'll show you how to actually train your model with our platform in a live demo. It just kind of would be more convenient here, but just bear with me for a second. Okay. I think that should be nice. Okay, so in order to train a model with our platform, all you need to do is use our API and upload the data, get a model training. So I'll be going through one example. You can see all of these examples at Disneyland/Disneyland examples. This is our GitHub repo with all the necessary tools, so you can follow this at home. I'm not really making anything new up. So this is really stuff that is publicly available. I'll be using this notebook. Just go through it, so you can take a look at how to train a model. So what we'll get started is a simple question answering model. So this is the bread and butter of small language models, of large language models, any LLM application. It's just text in, text out. So what we'll do today is first upload the data, then evaluate the teacher model. So that's the large language model we use for the distillation process. And that's a check for us whether we can solve this problem. So if a teacher model can solve this problem, arguably we can train a model, we can distill that problem-solving ability into the student model to get you started. Finally, we kick off the training, and then we can retrieve the trained model. So first of all, some notebook settings. This is nothing too exciting. We can go through with our authentication. If you go through, if you want to work with us, you'll get your own username and password, can log in. It's all boilerplate Python code. Finally, we reach the data validation. So this is what we'll take a look at in terms of what data do you need to upload. So the job description is the first component. This is just your prompt that describes the task. So you can take a look. The problem description is extremely straightforward. It's really about answer the question using information in the context. Question requires some additional inputs. But it's all very streamlined. There is nothing really significant there. You don't need to write page-long prompts to get this going. Then we take a look at the train and test data. So the train data are the question. Those are question, answers, and context tables, right? This is an SLM similar to your RAG system. you really just need to, for example, the question here would be, what year did Andy Carr appear in Rocky the Musical? 2012. You can infer that from the context. I think one thing that's very important to note is that we only take 50 training examples. That's everything that we need to get the job going. So essentially, you only need to write down 50 examples to have a fine-tuned SLM. This is something that you can do in an hour by yourself. There is nothing more to it. So here, I upload the test set as well. So the test set is a little bit larger, right? But that's because you want to have a robust evaluation protocol. Finally, unstructured data. Those are just about 1,000 different contexts. So you can think of it as paragraphs from your documentation, unlabeled inputs, anything that you have in abundance that you don't need to process. You can just upload stuff directly from your system. Right, so we set the config from the job. We upload the data to our API. Right, so API Distal Labs uploads. You just put the data there. This is data that I've just shown you. There is nothing more to it. You get the upload ID, hopefully in a second, yeah, and you can go ahead with teacher evaluation. So this is the step when we check if a large language model can solve your problem and how good it is, right? Because if you write a job description of guess what number I'm thinking of, obviously this is just not going to work. And there is no point training a model to guess what the number you're thinking of. So it's a check to verify that this problem is solvable. We use the upload ID that we have had before to get the training started. And then in a second, we will be able to see the results. So here the teacher evaluation is running, but I've had one that I've started before. So what you see are the metrics for the teacher model, right? So these are standard text classification metrics, question answering metrics. You know, I'm not going to bore you with the details now, but all in all, we should remember those numbers because they can give us an understanding of how the model should work. So finally, the SLM training, we kick off the training job using the same upload ID that we have had before. It's just API/training, and we get an ID of our training job. You can take a look at the status of the job, right? It's now pending. It takes about 10 hours to run, so obviously we're not going to be able to get the results here. But you can move, but you know, if we try to look at the evaluation results, it says that the job is still running. And we should use the status endpoint. However, I have trained one model before to show you how easy it is to get this going. So finally, the evaluation process for training is here. So if you remember previously, our teacher model had the following numbers. The Meteor score was 60 and the Rouge was 79. So if you take a look at the student base model, so that's the Llama 8 billion pre-trained model. So this is what you can download off Hugging Face, right? So this is the base model. You can get it instruction from Hugging Face. You can ask it to solve your problem, and it's not gonna do very well, right? If you can take this is in a few shot question answering setting. The metrics are 34 and 49 respectively, with a significant drop-off from the teacher model, right? So if you try to build your system based on the pre-trained small language models, they're just not going to work very well. I'm just speaking from experience. However, when you take a look at the student-tuned, so a model that is fine-tuned on 50 training examples and using our setup, the scores are almost on par with the teacher. So this is a different evaluation that runs here. The scores are a little bit higher. I think what it shows is that there is a variance in those results because we only have 100 examples. So what it means is that the student and the teacher are within one standard deviation of one another, which means that they're statistically the same. It's like the numbers are drawn from the same distribution. Even though the numbers are a little bit different, they're just kind of centered around the same mean. Right? And that is kind of the message that I want to leave you with. If you want to build a system with small language models, because they're efficient, because they run on-prem, if you use a pre-trained model, they're just going to work okay, but it's not going to be a very powerful system. However, if you fine-tune your models to become expert agents in every one of those domains, using just 50 training examples and your description, we can get them up to the same level as a 400 billion parameter large language model that is only hostable in the cloud. Right? That's kind of the message here. It doesn't take a lot of effort, but your results will be greatly improved. And finally, once the training is complete, our platform just gives you a download link that you can use to download the model for local deployment. So, of course, this is like 15 gigabytes because it's an 8 billion model, so maybe I'm not going to download it now. But the point is that you get the model and you have full ownership of your model. So there are no strings attached. You can do whatever you want with it. And the 8B model is something that can run on a more powerful laptop than mine, right? Not while I'm streaming my screen, but it's something that you can run locally. All right, so that's it for the demo. What I want to leave you with is our booth at 6E, and this is where we can give more details about our platform. So in the QR code, you will see an invitation to our webinar that we're running next week that will tell you more about what our platform is doing, how to fine-tune small language models for your applications. But if you're here today or tomorrow, just come to 6E. This is our booth. This is where you can explain everything in detail, get you set up with beta access so you can start training your own models and building multi-agent systems based on expert agents deployed locally. All right, thank you very much. I think we're just about at time.